So now let's just try this. This is our range. We're going to simplify this formula once. Okay, but that's our range here. So let's try this with our formulas. I think we launched at 34 squared, right? So this guy here is going to be, or I'm sorry, the velocity is 34 meters per second, right? This guy is going to be 9.8. Our angle was 56, right? So when you type this into your calculator, it's going to look just like this. 34 squared divided by 9.8 times 2 times sine 56 times cos 56. Such a lot of work. Type it into your calculator. Less work than solving the whole thing. I am crazy. Type that into your calculator. Don't put negative in. We're treating g as just like a constant here. Type that into your calculator. You could do that as soon as you type this into your calculator. Unless there's going to be puddles. Yes. Sine 56. It should be the same number times cos. Mine doesn't put parentheses in. Do you guys get 109.4 FM? Yay. Are we good so far? Yes. Everybody's done this. Even Megan, who doesn't have a calculator out, has done this. Did you do it? That? If I went over there right now and looked at your calculator, would I see that answer on it? All right, so there is a way to simplify this, and we do want to simplify it because we can't actually solve for the angle inside of sine theta cos theta. Can't be did, right? So there is a substitution we can make, and this is called the double angle theorem. The 2 sine theta cos theta is actually, all of that can be as the same as sine of twice the angle. Okay, so our new formula looks like this. And this is an exciting moment, okay, is that our range is equal to v squared over g sine of twice the angle. Isn't that exciting? So try that. Do that. Let's try that new formula, which is significantly simpler, right? This one's going to look like this. 34 squared times sine of twice 56 divided by 9.8. Try that. Type exactly that into your calculator. So 34 squared times sine. Then you have to use the parentheses. It's crazy. Do you get exactly the same numbers? Yes. Yeah, so this is not a rigorous proof that 2 sine theta cos theta equals sine of 2 theta, right? But it suggests that maybe it's on the right track, and it is. Okay, so this is our first formula. Now, let's suppose that we want to, instead of just predict where it's going to land, given like random v and random theta, let's suppose we want to actually hit the target. And that's what you're going to do later in the lab. You want to hit, and here it says that the range, that the target is at 54.1. Now you can either find the target by like reading the thing there and saying, yeah, it's probably 54.1, right? Or you can just look over here. It tells you right here on the screen where the target is, right? So let's suppose that we want to hit 54.1. Well, here's the simplest way to go. And I'll show you 2 ways. All you have to do is just pick one way and be successful at it. Okay? So what we're going to do is we're actually going to pick an angle, and I'm going to pick 45 degrees as my angle. Okay? I'm going to pick 45 degrees as my angle for a very good reason. Okay? Because what's the sine of twice 45? Take your calculator right now and find the sine of twice 45. It's 1. Why is that? Because twice 45 is 90. The sine of 90 is 1. It's like a definition of 9. It's the circle, right? It's like the y coordinate on the unit circle at 90 degrees is 1. Yes? Yeah? Shh. I know it's very exciting. Are we good so far? Okay, so here's what I'm going to do. Let's stick 45 degrees in for this, right? That makes this whole thing go away, right? And then we get basically that we want 54.1, which is what our range we want it to be, right? Is v squared over 9.8, right? And then sine of twice the angle is just going to be 1. Yeah? So take your calculator right now and solve for what v has to be, which is going to be something slower than 34, right? Solve for what v has to be to hit that target. Because the sine of 45 degrees is twice 45 is 1. Didn't we just do that? Yeah. Okay, so I'm going to do this in 2 steps. And then how do I solve this for what v is? Everybody's calculating. Chris is calculating. He's touching a calculator. Chris, calculator.
I have one.
You came to my class without a calculator?
I have one.
Well, get it out. What are you even doing?
Getting my calculator out.
Everybody's calculating. They're excited about calculating.
Getting my calculator in the process.
Do you guys get something like 23? Yeah, there we go. Okay, so this is our first way to do this.
Just bump up the degree so we hit our target.
Well, we don't bump it up, right?
Maybe.
Okay, so let's pretend, boys and girls,
Boys and girls. Shut up.
when we do this, we're not going to be like trial and error. There's no sense that we're going to do trial and error here. We got to deliver that parcel the first time, right? Let's pretend that see, isn't it bad if you've got like a little rocket or something that's going to kill a tank? Isn't it bad to miss the tank? Yeah. Yeah, because you're A, not in a tank, and B, tanks are a whole lot better at hurling missiles than you are, right? So if you miss the tank, it's going to go, what was that? And then you're going to be gone, right? So we got to hit this thing the first time, right? So what did we say? We said our angle is 45. And yeah, we're in serious trouble if 23.03 does not work. So here we go. Are we ready? Direct hit. Yes. All right. Okay, so that's way number 1. That's very simple. Okay. Why didn't we do that when we were outside launching rockets? Why couldn't we just say, okay, let's launch this rocket at 23 meters per second? Yes?
Well, not that, but for fun, can we just shoot it straight up at a really fast speed and see if it comes out?
Oh yeah, probably will. Let's try that. Launch angle of 90.
No, don't do that because it's just going to be straight.
No, it's straight up.
Yeah, straight up.
Missed. I hit myself.
Yeah, see, you got to go 89.9 and then shoot it at 100 miles per hour. Whoa!
I still missed, right?
Yeah. How fast?
Okay, so why did we not, when we did the rocket competition, why did we not calculate what the velocity was and then change the rockets so that they would launch at that velocity? How would you change the velocity? They only launched at a particular velocity, right? So this is the deal. What we have to do is we also need a way to solve. We could change the angle to anything we wanted, right? Okay. So now let's solve this thing for what the angle is. Okay. So let's solve this formula for the angle. How do we solve that formula for angle? It's inside a trig function. Ultimately, aren't we going to have to do like an inverse trig function? Yes? But don't we have to get the trig function all by itself? Don't we? So what do we do? What's our first step to getting theta by itself? Multiply by what? Yeah, multiply by g, right? Which somewhat surprisingly gives us